Now for some key knowledge. Have you revised this topic yet? Key vocabulary, pedigree analysis chart. This is to show how genetic disorders are inherited in a family. They can use this to work out the probability that someone in the family will inherit a condition. Understanding charts. 1. Okay, nice basic pedigree chart here. As you can see, we have people represented as squares and circles. Males are represented as squares, females as circles. We've got 3 generations of family here, okay, with number 1 being the older generation. The horizontal lines between males and females show that they have produced children. This analysis shows both males and females are affected, and every generation has affected individuals. Understanding charts 2. Again, we have 3 generations. The second generation shows that all offspring are symptomless. Child 1 has had children with another symptomless male. However, we see that in the generation that follows, there is an affected female. If both parents are unaffected and the offspring is affected, the trait must be recessive. We would say that the parents are heterozygous carriers. Worked example. Cram is an inherited condition which causes muscle breakdown. The breakdown products enter urine, making it dark coloured. The diagram below shows the inheritance of cram in one family. Now, this is something you won't have been taught about. You'll go, what is cram? Okay, it's just another inherited condition. You could look through the family tree and you could annotate this diagram. So we've got the 3 generations. We can see again that the second generation are symptomless. However, in the 3rd generation, we do have an individual that has cram. So before I'd even start the question, I may be annotating this diagram. Now for the questions. Question 1, give evidence from the diagram that cram is caused by a recessive allele. For this, I would go straight to generation 2. Parents 7 and 8, they are unaffected, however, they have an affected child. Number 2, person 2 is homozygous. Don't really need to highlight this. However, what does that mean? That means that they carry both of the same alleles. Question 3. None of person's 2 children have cram. Explain why. This would be because of person number 1. Okay, their father. The father would have a dominant allele, and the children will inherit the dominant allele from their father. Question 4. Person 7 and 8 want to have another child. What is the probability that this child will have cram? Draw a genetic diagram to explain your answer. We've been given these details now of how to represent the alleles. 7 and 8, remember they are symptomless. However, because they have an affected child already, they must carry the allele for Cram. They are heterozygous in their genotype, so this is how you'd represent that for both parents, and then complete the diagram. Double recessive will be a child with Cram. That's 1 out of 4, so the probability is 0.25. You can now check my answers against the GCSE mark scheme. If you wish, you could go back and have a look at the questions again. And here's the diagram that should have been produced. So making sure that you've got the correct genotypes, completing the diagram, identifying double recessive as Cram, and giving the probability. Time for a question. Now for some practice, the diagram shows a family tree in which some individuals have an inherited disorder which may cause serious long-term health problems. Again, we have 3 generations. We have people affected in every generation. Take a minute to look at this diagram and possibly annotate it. Here's the GCSE mark scheme. Practice part been given to find number of moles. Explain the evidence from the diagram which shows that the allele marks been given to find the mass of the iron. Give an answer. Use the appropriate letters to identify individuals in your answer. You may use genetic diagrams again in your explanation. 5-mark question. If it says that you can use genetic diagrams, it may be a good idea to do so. Pause the video and have a go. How did you get on? So you could have looked at either C and D or A and B. For C and D, lots of points included, less so for A and B. Look at your answer, give it a mark. You're looking for 3 marks on this question. Practice part 2. A doctor suggests that couple C and D should have their embryos screened, but that couple, G and H, do not need this procedure. Explain the reasons for the doctor's suggestions. Again, maybe take a look back at the diagram. If we're having an explain question, we've got to give reasons. You've got to say why. Pause the video and have a go. How did you get on? Again, a 3-mark question, 5 points given there. Give yourself a mark out of 3. Practice 2. Stickler syndrome is caused by the inheritance of a dominant allele. Figure 6 shows the inheritance of Stickler syndrome in 2 families. In the diagram below, we have 2 pedigree charts next to each other. Use the following symbols in your answers to questions. Capital A, the dominant allele, lowercase a, the recessive allele. Now for a question. Explain why none of the children of persons 7 and 8 have Stickler syndrome. 2 marks, 2 points. Pause the video, answer the question, and then look at the GCSE mark scheme. Here's the mark scheme for question 1. 7 and 8, the parents do not have the dominant allele, capital A. Other examples of answers where they are double recessive, lowercase a. And then for the further mark, one of the other 4 points to be included. Question 2. Person 12 marries person 18. Use a Punnett square diagram to find the probability that their first child will be a female with Stickler syndrome. Okay, remember we're using capital A and lowercase a to represent our alleles. Pause the video and have a go. Here's the GCSE mark scheme and a Punnett square that has been completed for you. So both parents will be heterozygous in their genotype. Complete the Punnett square. Identification of AA as Stickler. Therefore, the probability would be 1 in 2, so a 50% chance.